Hello, everybody. Welcome back to another live stream. Or if this is your first time, welcome to our live stream. I have a long list of questions that I kind of have a backlog of where, you guys ask questions, and I wanted to kind of just hit the most common ones today. Because I always joke during the live streams, you ask something, and I'm like, man, I wish I had the link for that. Well, today, hopefully, I prepared some links and some info. But the ones that you actually ask in the chat will take priority over this list. But yeah, this is kind of the 20, I won't say the most common, but these are very popular questions that probably as you're starting out, you're kind of curious about PLCs. So the first one is what is a PLC and how does it work? And that's always such a broad question to get. But well, first of all, this is a PLC. And for the most part, it takes inputs such as these buttons and switches right here, does some type of decision making, and then updates some type of output such as a light, a motor, a solenoid, or something like that. So just equating it to us, I have my eyes. I just read that question. So from me, the question that somebody posted there, me reading that, I'm using my eyes, that's an input. And then my brain's kind of processing it. And now I'm talking to you, telling you the answer. That's the output. Now, some things get a little gray on that. So, like if I pick up this can here, this took an output for me to grip this can. But I also need to know how much am I gripping it, because if I grip too much, I can start smashing the can. So my hand is both an input and an output. And I would equate that to a lot of the process control that we see out there. Let's see. Yes, yes. And again, I'm here learning from you. Well, I'm glad you're here today. Yeah, if you're out there, go ahead and drop your name in the chat, say hi, and yeah, whatever questions you had, go ahead and drop those in there. But along with that, let's see, I did drop some links. So let's see, what is a PLC and how does it work? This right here is a really good video to watch. The next is what are the main components of PLC? And this is something that I'm actually getting ready to make a video on. I don't actually have this particular video yet, but this is something I've been building out. This is actually our getting familiar with your PLC trainer, but it really kind of breaks down a lot of those common items and kind of gives us a little bit of an overview of what it is. But if you really want to get in the weeds of what all the little doodads and everything are, this is a great link, and hopefully there'll be a video there soon. But for now, this is a good one, so let me drop it in there. Whoops. Let's see, where is that one? There you go. Let's see, then what programming languages are used to program PLCs? And this is probably the most contested question I get. In fact, there was just, this is a weekly discussion somewhere. And the difficult part is there is no clear answer. No, so for the most part, there are three popular languages that are used in PLCs. Now, with modern PLCs, I mean, the lines are so blurred between what's a PLC and what's a PC that's just industrial grade now. But popularity wise, you have ladder logic, function block diagram, and structured text. Those are the big three. And probably at least once a week somebody says, well, why are you even bothering teaching ladder logic now? And this is something I went on a rant about in one video. I'll try not to go on a rant about here. But my thing for people that are saying that is the base of, and I'm in the USA, the base of what we use here language wise is ladder logic. So if we were to cut off and just say, hey, you can't make any more programs that are ladder logic today, well, most of the equipment out in the field's 10 or 20 years old. So for the next 10 or 20 years, people still need to know ladder logic. But ladder logic in the US is the most common. It's absolutely the one I would say learn first. Nowhere in that sentence did I say it's the best, but it's going to give you the most marketable skills the quickest to get you a job. And that's really my goal. Function block diagrams is another real, I'll call it a visual platform to kind of follow what's going on, and different manufacturers do better and worse jobs at making that happen. But I see a lot of it in the oil and gas and process control industry. And then you have structured text. And, if you're coming from the software world or anything like that, it's what you know. And here's where all of a sudden we have the kind of the butting of the heads is, yeah, I know it's what you know in the software world, but it doesn't mean it's the best language. And this is the part that I really want to do a video on sometime, is really talking about the cost of that decision, because people will tell me all the time, well, I can write a structured text program faster. I won't argue that. I can write a structured text program probably faster also. Um, but downtime is the most expensive part of a machine's life cycle. So great that you can write it and shave some time off, but how much more time will it take somebody to troubleshoot? People tell me all the time, well, but they just need to go learn structured text. No doubt. I'm not saying technicians don't need to know structured text or function block diagram, but the goal of any maintenance manager is to have a technician that can go from one machine to the next machine to the next machine to the next machine and troubleshoot with a pretty even set of skills. So from their perspective, yeah, you may have been able to write a more efficient program. And people tell me all the time, all you got to do is be able to read. Well, okay, I get that, but it doesn't quite have the interface that, they're used to. Let's see. How do you write a simple ladder program? Well, I'm going to drop a video in for that one, because we did this live stream right here that kind of talked through a basic program, one, downloading your software, how to, select your PLC type, how to do your basic creation. And, those go look for one, go look for zero, output, energize instructions. If you know those three, then you can bumble your way through probably at least half the programs out there, maybe 60, 70% of them. So that goes through that and then kind of hits timers, and that right there will get you a pretty good ways. Okay, so let's see. Oh, Trey, good evening, teacher. Coming from Vietnam. That's great. I'm glad to see you here. See, let's see. Want to know the concept of parity in Modbus communication. Can you explain it a little? And there's where I got to admit, for the most part, I'm usually just swapping those terms until the thing finally starts to talk. I really, baud rate is the speed. You have stop bits, which is usually none, one, or two. I don't even know what that means. And yeah, parity. Yeah, I don't know those. So no, I probably can't. I'm more on that part of, we'd end up Googling it, figuring out how to make it work. Or yeah, that's one thing I love about RS links. And, when you're going to configure a serial driver, you get that auto configure button, and I see it up there. All it's doing is swapping all those terms. And yeah, I'm just usually celebrating by the time I finally get it going. That wouldn't be a bad rabbit trail one day, though, or even putting a scope on a serial line just so we can kind of see, in the crude Morse code. I don't know what you would call it exactly. Dewan, sir, I have Allen Bradley PLC module. It's missing PDL memory card. How can I replace it and communicate PLC in my computer? I'm not sure what you mean by a PDL memory card. So you have an Allen Bradley PLC, the PLC memory card. How can I replace it and communicate? Well, what type of PLC is it? I get the feeling that was PLC. What type of PLC is it? That would be the question on that one. Cameron, how deep into networking should a PLC tech get? Should a CCNA be too much? That's a question that's really quickly evolving. In fact, that is a question that's somewhere over here. So you're asking what are the common questions there? In the end, what I would say is they don't need to go that deep, because in the end, I shouldn't say that. You could have a bad Ethernet port or something. But for the most part, they're trying to find that sensor that's hanging off of that thing and get it replaced, or find that motor that's burned up, things like that. So as far as networking, they do need to understand the basics of IP addresses. They do need to understand some basic network diagnostics. We need to do a better job at equipping our machines with networking tools to help that troubleshooting. And that's something we're actually building out right now. Josh Vargas, I went to his Traceroute Con, and the big thing he pushed is, we've got to start, really get rid of using unmanaged switches. And everybody said, well, we don't really need to configure it. Well, after going to his class, he completely changed my mind on that because, yeah, we don't need to configure it, but it does give us tools to help diagnose our networks. Now, occasionally we may need to send it to someone like Josh to say, hey, my network's slow, what's going on? But at least we have some type of tools to get us through that. But I always say there's no training that is not worthwhile. It's kind of where I'm also at with that. So, Cameron, what I would say is send one to it would be where to start and see what they get back out of it. Because there's no doubt right now we're definitely in a very quickly changing market as far as Ethernet. I mean, used to, you'd have a few devices on Ethernet. Usually you'd have that HMI talking to that PLC. Well, I should talk about this one too. But, here's kind of where we've evolved to. I get this scooch. Yeah, I mean, used to you'd kind of have a PLC talking to an HMI, and we'd have some unmanaged switch or maybe even a hub kind of talking those together. And then, we started adding drives and things to kind of save, some panel wiring and give us a little more diagnostics. And now, this linear actuator, it's operated off of Ethernet. We have IO link over here that's giving us, actual distance information and various sensors, picking up this encoder. So it is something, put it this way, just to kind of go back on that a little bit, Cameron, is we did not hold one of our December classes because we're doing a major upgrade. And the two big upgrades we did is we actually I can say this, we replaced every single piece of networking hardware in here with something to kind of start teaching about that networking component and safety, which coincidentally, that's what this trainer is for, is hopefully so we can talk a little more about safety. So yeah, I guess in that case, yeah, it probably might be worthwhile. All right. Hey, there's Brad. How you doing, Brad? Let's see. Still interested in understanding the PID instruction before version 21. Specifically, how do you elegantly take the instruction offline for manual control? And that is a really good one there. In fact, a little bit about what's coming up is we have probably one lesson left of the Micro 850 because we kind of started over and just redid the Micro 850 because some of the lessons were dated. But the last one of that is PID. And then I'm actually going to do the whole thing in Studio 5000. And you're right, we have the PIDE and we have the PID. But that manual control, actually, I tell you, the manual control really trips you up on this. This actually what delayed this one because I got looking at it. There wasn't really manual control. Now there is on Studio. So yeah, that's one to definitely, I'll make sure I cover in that. Let's see, how often do run the instruction and compare parameters in PID data type? Any advice for tuning? Is there a way to see the current value of the value? I probably need to brush up on pre 21 because, yeah, I'm not going to be familiar enough with it. I'm not going to be able to pop up something fast enough on that. I'm trying to remember when the tuning went into Studio 5000. Is the auto tune button there in that? Or we can get that other dialog box up. Let me at least pop open a program. Let's see. This one has a PID. Bradley, help me out here, Brad. I'm sorry. Brad, not Bradley. Is when you're looking at it in Studio 5000, are you using the PID or are you using the basic PID? Are you using the PIDE or the basic PID? And actually, I'm remembering your program now. I think you're using the PID. And I don't think it has the auto tune. I need to brush up on that. Oh, there you go, right there. You're using the PID, not the PIDE. So, yes, that that would be worthwhile because I think that's probably one. Talking about that's kind of what this video is about. Is those questions that I keep getting that I don't cover well. There is a little bit of confusion there between the PID and the PIDE, even in the way the equation works in them, and that would be worthwhile to do. Kind of, well, yeah, A to B, not A B, but A to B comparison of those two instructions. So let me go ahead and make a note of that one here. All right. Um, let's see. Eric, I see a large amount of Rockwell training online. Do you have Siemens DCS training as well? So we are building out, and I will go ahead and put the link. It is a very weak link right now, but if, like, in fact, let me just drive us there. Let's see. If we go to courses.twcontrols.com, then you can see our kind of what we'll call our premier lessons right here. And yeah, there's Studio 5000 connected components, like you were saying. And then the industrial control one, this RS500's getting more data. You'll probably see it go away, maybe even this year. And actually, this one's going through a major revision right now. But along with that, we have lessons in development. And the more interest there are in these, the more videos we do. So actually this automation project from concept to reality, it's going to replace this control panel building, kind of zooming out a little bit more and talking through it. So eventually all this content will go into there. And then we have inductive automation, and y'all have shown really good interest in it, so we'll probably continue it on. And yes, we have this S7 1200 and 1500 for TIA portal, and we are going to continue it on, along with another link I'm going to give you here is Vlad's lessons. If you don't know Vlad with Solus PLC, let's see, Solus PLC. Because we're actually teaming up with him on this, or we're not teaming up. We have a PLC trainer now. In fact, if we just go to TW controls, whoops, where's TW controls? Oh, that's our class schedule. If we go to products, then you notice that we have some Siemens trainers now available, and they use the Siemens HMI and the S7 1200. But they come with Solus PLC's lessons. And if we go over here to his courses in PLC programming, he has some really good TIE portal lessons. So I kind of would lean towards that one right there. Let's see. Scion. Benefits of using Modbus TCP to collect data from various PLCs. Example, Compact Logics, click. So, I don't know if there's actually an advantage as much as it's a tool that we can use to get data. So, what are you trying to data log to would be the question. So, I mean, if it's a Compact Logics, rarely would I actually use Modbus TCP unless the particular thing I'm trying to log to doesn't support it. Now, a lot of people will tell you that the Compact Logics doesn't support. Let's see if I get a link up here. I need that master link list, but a lot of people will tell you that the Compact Logics doesn't support Modbus TCP, but it does through an add-on instruction. And let me see if I can find a video that has that. Actually, here you go. Here is Modbus for Allen Bradley PLCs. I think this covers Connected Components Workbench and Studio 5000. So let's see, Studio 5000 and CCW Modbus TCP. Let's see, usually data flowing through Compact Logic at various points, making transfer sensors, but still, what is your end thing that you're actually collecting, or your data logging to would be the question on that. Or are you saying that you're collecting from like a Click PLC to a Compact Logics? Now, I believe the Click PLC actually supports Ethernet IP. I believe you can drop it as a generic device. I've never actually tried it before. Not sure I have a Click PLC around right now, but yeah, yeah, let me know on that. Yeah, okay, but you say weigh scales, temperature, pH. I get that, but what are you collecting them through? Are they just wired right into the to your compact logics? I mean, if so, there's no need for the Modbus TCP. All right, where are we at? Divas, what it actually means if you select yeah, see, I vaguely, what do the baud parity and stop bits mean? I'm really not that familiar with it. I remember you just usually kept swapping them until finally it worked. They definitely have a definition, but I do not know what they actually are. Let's see. I got Eric there. Here's where I need Amber's out of town. Here's where it helps to figure out. Okay, what did I got? I would like to hear more about Siemens training. Okay, so I just talked about that. Check out Solus PLC. Because even now, I'll go ahead and elaborate a little bit on that. We're not going to go in depth in the TIA portal. Probably, I'm going to hit those basics. I think Vlad over at Solus PLC has excellent content. And I don't like to duplicate content, but what I see a need for technicians, people coming to my class, and probably a lot of you, is you either have a Siemens plant and you have that one Allen Bradley PLC, or you have an Allen Bradley plant and you have that one Siemens PLC, and everybody's like, yeah, we hope that doesn't break. Well, it's not that bad. You know, figuring out how those little odd, mainly communications, figuring out how to connect to the PLC. If you can get past that, you can troubleshoot either one of them. But what I want to work on is kind of a Studio 5000 to TIA portal. How do you look at one program and equate, what you're seeing to the other program, and kind of make us a little more versed at the two platforms. See, Jason, your training videos are awesome. Well, thank you, Jason. I appreciate that. Good morning, Jeff Kuiper. I just got off the phone with you a little bit ago. Good to see you. Let's see, any experience with Omron? I have very limited experience with Omron. I mean, very similar to what I just said. I can troubleshoot Omron. I've connected to it. Again, if you can get connected to it, that's the challenge. Then chances are you're golden. In fact, I can't say there's anything majorly different between that. And I'm trying to vaguely remember now. I believe, yeah, I mean, I think it's the same as all of them. It's figuring out the cabling to connect to it. After that, it's pretty much the same. Let's see, okay, we talked about that. Jeff Kuiper. Oh, yeah, okay. Jeff just said a click can be an Ethernet IP slave. So I assume that means then you could pass some information right across between the two of them, and that would be good. Let's see. Let's see, Alejandro, can you drop that through a Google Translate? That way I can figure out what you're saying there. Because yeah, let me go back over to our other question list and see where we're at on this. So where got that one. All right, we kind of talked a little bit about what's the difference between ladder logic and function block. A little bit more on that. What I always tell people, it's very regional. If you're in the U.S., especially anything that kind of was built up, we'll say, around our traditional industries, it's going to be ladder logic. And it did, stem from, the replacement of relays. I don't like to get too much in the history of PLC, but more than anything, if you're getting one from Europe, they really didn't grow up the same way. So I would say European equipment, you'll see a lot of function block diagrams. US, you'll see a lot of ladder logic. And you need to be versed in both of them is what I always tell everybody. Everybody always wants to know which one's better. Nothing. They all have a place, but more than anything, you're gonna run into them. You gotta know them. Let's see. Now, what? Yeah, this one came in just a little bit ago. What is the best I/O modules for a PLC system? And used to I would have said, well, all you got to know is it are you doing 24 volt? Are you doing 120 volt? Is it syncing? Is it sourcing? And you're done. But now that's a much broader question because now we have IO link and all this stuff, and the closer we can, or we'll say the shorter we can make the run of wire on a machine, the better off we are. So you're seeing a lot more, although this is the in-cabinet version, you're seeing a lot more, things like this IO link. So this module could be out right near the machine or right near the part. It can pick up 4 IO link devices and then shoot it over Ethernet. So this way we only have to run a power wire and an Ethernet wire. And you can get these into, you know, like 16 port IO link modules. And even then, one port on an IO link is not necessarily one sensor, because you can get these sensor hubs on for IO link, and we can pick up like 8 sensors on one IO link. So, you know, which one is the best is still a tough question without, you know, it's more application dependent, but you know, which one, I always say the more we can minimize the wiring, the better we're going to be. We're going to be better in longevity wise. We're going to be better building equipment because, you know, on average, it takes 4 minutes to wire. By the time you know, cut the wire, ferrule the wire, or strip the wire, ferrule the wire, print the wire label, put the label on, do all the things, people average on average 4 minutes. So every wire you can eliminate, you're saving 4 minutes. And as the machine ages or is having issues, there's one less wire that we have to troubleshoot. See, how do you connect sensors and actuators to a PLC? So I just did this video. In fact, this video is not even out yet, but right here, there's a video I just did on how to really read a sensor diagram and figure out how to wire it to your PLC. Actually, there's several versions of it. I have it because here's what it basically is. We have a laser sensor here. We have an inductive prox, and we have a capacitive prox. You know, understanding these, looking at the diagram, figuring out, okay, how do I look at this and figure out, is it syncing, is it sourcing, or in their cases, usually, is it PNP, is it NPN? Then, you know, what can we handle in our PLC? In this 800s case, it can be syncing or sourcing. Okay, then what do we got to do? But yeah, that video there, in fact, that video and 2 others go through it. And they should be out soon. In fact, I think the one I just dropped in there, I'm not even sure it has a title yet. Let's see, what is the scan cycle for a PLC program? Yeah, it's a tough question. I have videos on both, but I wish I had the compact logics here. I need to make a trainer that has the 850 and the compact logics on it. I really should do that. Actually, that might be a good trainer just to have to sell. But so in the Micro 850, what I always call the traditional PLC. Now, traditional does not mean old, because it does include your Slick 500s. It includes your Micrologics, but this Micro 850 just came out last year, so it also includes moderns. But they're going to read their inputs, which is pretty much the status of all these sensors, buttons, and things like that. It's going to run some type of program, whether it be ladder logic, function block diagram, structured text, or a combination of all three, which is probably what you're seeing more of in modern PLCs. And then it's going to update its outputs accordingly. And then it's going to go around and do it again. It's going to do that incredibly fast. And we're talking on most PLCs now, like millisecond range, maybe sub millisecond range. Now that's the traditional PLC. Now the ControlLogix PLC operates differently. And so what it does, that's what we call a synchronous scan. Do this, this, and this. The ControlLogix, it can gather, in CompactLogic Studio 5000, it actually gathers data at what's called an RPI and grabs it at different, you know, rates depending on what it is. And then it has different types of tasks. So we can have our continuous task, which kind of like that, just runs as fast as it can. But we also have periodic tasks. So maybe we have something that needs to be really repeatable. So we can use a periodic task. And you also have event tasks that at the moment something happens, it can run, but it doesn't run normally. And right here's a video that talks more about that. Go. Let's see. Oops, that was the wrong one. Did I just put the, oops, I just put the sensor one twice. Let's try this one right here. There we go. That's the one we wanted. Let's see. How do you troubleshoot a PLC program? That's my favorite question. Because obviously that's pretty much what I do for a living, is train you on how to troubleshoot PLCs. And, you know, I've got a really good video on it. It's kind of comical. Well, the video is not comical. There's so, you know, and it's the same deal I have with a lot of people that come to my classes. I'm going to go ahead and drop this in there. But one of the biggest complaints is you talk too much. We need more action. And When people come to my class, they want to immediately do something. They got to have the leads in their hand. They got to be scrolling. I'm like, do you get paid by the mouse click? Do you get paid to scroll? I mean, do you get paid by the point that you probe with the meter? I said, let's just step back. What do we observe about the machine? Mainly, what's the action item it's not doing? Okay, I want this green light to light up right here. Okay, where's the green light go to? It's going to be an output. We go find that. We figure out what its address is, and then we can work its way back into the program. And that whole video kind of walks us through that, and then figure out what's missing. Usually it's an input, but it's interesting. Most people do the opposite because, even if you know nothing about PLCs and you call someone and say, hey, the green light won't turn on. I don't even know what program's in this thing. Not enough to do anything, apparently. Um, but if they say the green light, I say green light, we would never call for that. Say the motor won't run, the pump is not pumping. You call the programmer, they're never going to tell you, go look at the pump. Well, no, they're going to say, well, go check out the gate switch. Go check out the low level. They're going to tell you to go check those inputs that they're looking through the program, trying to figure out which one is not working. And so the goal to troubleshooting, though, is start at the action item, that thing that is obviously not doing what you want. Now, they've done that step for you, but it's a small difference, but that takes us from just kind of doing exploratory surgery on all our inputs to actually finding the thing. But anyway, if you go in that video, a lot of people are like, oh, you talked too much. We needed to learn more about how to use the meter. Well, no, you didn't. You needed to learn how to think through the problem. And yeah, I'll probably do a follow-up on that one. Let's see, what are some common programming mistakes that people make? Well, I believe that if you're not making mistakes, then you're not trying hard enough. So I would say that what are the most common learning opportunities that make us better programmers? And probably the biggest one is duplicate destructive bits. That is by far the one that gets people the most. In fact, I was recently did a series on the Festo Didactic MATLAB, and I fell right into it. What's funny, and it's a perfect example. Let me see if I can find that one fast enough. Duplicate, there it is. Of course, y'all know I can't type and talk at the same time. So let's see, duplicate, destructive bits. Um, there we go. I made it through the whole series. Like I was editing the videos. It was done. The machine worked perfectly. And I was looking at it while I'm editing. I'm like, oh my goodness. I have a duplicate destructive bit right there. And so those things can lay there just waiting for, ever. And all of a sudden, the right circumstances happen, usually a broken sensor, that makes that thing cause us grief. Now, I know what a lot of you are going to say right away, and yeah, you probably will put it in the comments if it's not live. So listen up. A lot of people say, well, there's a warning in Studio for that. There is. But first of all, duplicate destructive bits are not necessarily wrong. I see lots of programs that have them, and the way they're used, they're perfectly fine. The other thing is in a larger program, you're going to have like 300 warnings. It's normal. Nobody is going to look at those and see the duplicate destructive bit warning. So really going back to thinking through, finding the output, and then we did in that video, we talked about cross-referencing. When we cross-reference, we would see the two destructive bits. That'd be the first time we'd realize we have a duplicate destructive bit. Beyond that, probably, and again, I don't want to call it a mistake because, in the end, if the program does what you want, then it's good. But probably what I see new programmers do, mainly because they glaze over my PLC scan video, and that's 100% of why, is they don't fully understand how the PLC scans. And so they're over-relied on latches and unlatches. Nothing wrong with latches and unlatches. I know a lot of you out there are like, no, we don't allow them in our plant. I'm like, okay, are there any other instructions you don't allow in your plant? I mean, we need to understand them. But since we don't understand how the program really scans, we don't know how to sequence machine logic, then we're over reliant on latches and unlatches. That's a really good one. Let's see. Sequencing. If I can find it fast enough. That's always the challenge. Sequencing. Oh man. Apparently I have 14 sequencing videos. Where's the big sequencing video? Here we go. Copy that. Let's see. Sequencing machine steps. So this one right here kind of goes through different ways to sequence machine steps. And I believe if we understand those, actually that video right there is probably the golden video that if people actually get to in our course and go through, they're they're probably set after that if they really take their time through it. But after that, probably underestimating a project scope is what I would say. We all start off thinking, well, I got to come in under budget. And don't get me wrong, budgets are important. But yeah, I've blown many a budgets. But early on, I thought, oh man, I got to stay within this. And I would realize, oh man, I made an oversight. Well, instead of just being like, something, I made a mistake and this is going to cost us 15% more. I would try to, just try to stay in that, stay under that budget. And in the end, and I do have one that is just, in a terrible example of it, but instead of it costing us like 15% more up front, by the time, really, but if you cumulatively add up, by the time we had the downtime, the grief, the customer unhappy and everything, we probably were 300% over budget in the end. But so yeah, that would probably be the next one, is that piece right there. All right, let me catch up a little bit over here on the chat. Let's see. What do you think about Omron? I did that. Let's see, Brian. Hi, Tim. I've enjoyed many of your videos, some even from the plant floor when I get stuck. You and your team are awesome. Well, I appreciate that. And I will definitely share that with Amber and Mary Bruce. It's always good to hear. Hangout. Signed up for all the free stuff at Solus PLC. Yeah. Make sure you see tell Vlad I sent you. But yes, a lot of people are like, oh, you know, they're kind of surprised that a lot of us end up knowing each other. We're a small community, So yeah, I know Vlad, at Solus PLC. I was just talking to Timothy Gates, the PLC professor. That's another really good one. He's on YouTube, and he actually I would argue, has the best books out there as far as practical hands-on things to learn about. But yeah, we're a small community. We all need to know each other. Let's see. Hi, or hi, okay, no on. Let's see. Let's see. Oh man, sound effects. So, well, you spelled it. I had to sit there and sound that out. Let's see. I'm starting my journey to become a PLC programmer. I'm starting the prerequisite class for electrical. From there, taking a PLC automation course through trade. Any advice on the fundamentals? The biggest thing is, and actually I should revise this video, although I'd say the same thing, but it's dated, as pick the one that is most common in your area. This is what I tell every people all the time. Don't ask me what PLC you should learn. Don't go to LinkedIn, ask them what PLC you should learn. Don't go to Reddit, ask them what PLC you should learn. And don't go to the local electrical supply house and ask them what PLC you can learn. Because one, they're going to tell you the one they sell. But the rest of us, we don't know about you right in your town. So ways you can figure it out is, one, look at the they used to be called help wanted ads, the job listings in your area, and see which PLCs most manufacturers are asking for, and pick that one, because that's going to give you the most marketable job skills. Also, if you can't find that, look at people that are already in the industry in your area again and ask them, hey, what all do you have to work on? What software do you have to work with? Now, the next one is, there is a free version for almost every PLC software out there. Even Allen Bradley, and I know everybody says, "Oh no, Allen Bradley software costs $10,000." No, it doesn't. Connected Components Workbench is free. The paid version of Connected Components Workbench is less than $200. The entry level of Studio 5000, I think, is $500 or $600. I mean, but there's still dollar signs. Is I want you to start off with free software because you got to make sure the newness, it's not just a new thing, and you're not going to move on to something else. I'm not saying you are. I don't even know you. But my thing is, if you buy this trainer, you can sell it on eBay for probably almost the same thing that you purchased it for. You cannot resell software. So you're going to be out that money. So find free software, common platform, and practice, 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 practice. Once you even, you feel like, and when I say practice, go through, in fact, let's see, let's just go over here. We'll talk a little bit about it here. So I have this program open here. It doesn't matter. I'm not going through it really, but in fact, there you go. This isn't exactly where you're going to start a blank wrong. I want you to go to the first tab, which is the favorites tab. And I want you to understand every single one of these instructions. And when I say understand them, that doesn't mean drag them down, hit a button, see a light turn on, and say, woohoo, let's go on to the next one. It's really, what does it do when it's true? What does it do when it's false? What is this one? What does each one of them do? Because in the end, they're true, they're false, and they do stuff depending on that. And, but just work your way through all the categories. And eventually you're going to get to some that are, you're going to really struggle a little bit to understand the application of them. And this first categories, the bits one, really, if you understand it, that's what I was saying earlier, you can probably follow 50% of the programs. But the timer counter, the compares, the maths, those you can build out. And then all of a sudden you're going to get into like motion, equipment phase. They're going to get a point where all of a sudden it's gray as to what it would even do. And at that point, you need some practical applications. And the best way still I feel to do it is Mr. PLC and PLCs.net. These are two places that people ask questions. One, if you have questions, ask them there, but also start reading other people's questions and start trying to solve their problems and read through how are other people solving it. Put other people's solutions in to your program and see how they work compared to what you're thinking. Here's where going back to what's the best language, what's the best programming method. It's the one that works in the end. So, and probably early in my career, yes, if y'all look at my early post, I know I did it too, but we're so worried about being right sometimes. It's not important that we're right. It's important that we understand the different viewpoints that people will be coming at it from. But yeah, so yeah, that was a long answer, but in the end, PLC that's common in your area, free software, practice. That'll get you there. All right, let's see. One, how to program HMI for Allen Bradley, and what is Allen Bradley simulator software name? So go to the Connected Components Workbench course. In fact, let's see. This right here, this software is free. Connected Components Workbench course. So the Connected Components Workbench you can download from free from Allen Bradley. It does have the simulator built in. Also, you can use it to program the PanelView 800, which is a good economical HMI. Actually, Connected Components Workbench, you can also use to program this PowerFlex 525 and actually this CR30 configurable safety relay. So very, very, well-rounded program for starting out learning. Let's see. Brian, any recommendations for remote support devices from PLCs, gateways such as the E1 TOSI box? The problem I am running into is finding a device for multiple subnets. So yes, that's what we just did this whole upgrade of this training center for, is we are actually going to do a bunch of videos on kind of that IT OT convergence and then getting out remote. I'm not going to nail down the exact answer for you because what I really want us to understand with that is, one, there is no perfect answer. It's always about reducing risk. Actually, I would put safety and networking in the same category. We can never eliminate the risk of an accident, although we want to do the best we can. We can never eliminate, a network intrusion. But we want to do the best we can. So I'm actually going to do a video on, what happens if we just open up a port out on the internet? And yeah, you can find PLCs out on the internet all day long like that. And then what happens if we have an air gap network? That's the one that probably is the most vulnerable network out there. People tell me, they come to class, yeah, we have an air gap network. We don't have to worry about any of that. And what's funny is I had one class one time. I mean, it was literally the guy across from him. He's like, I got a cell modem. Anytime that I have an air gap network and they won't let me monitor my machine and I'm having issues, I plug that cell modem in. So at that point, you have a network that is completely accessible to everything. So yeah, great question. I don't have the answer yet. That's been a big learning experience for me, is learning, kind of, you said, segmentation, dealing with those different layers, how, we probably swung way too far with the E1s and the TOSI boxes and all that. I saw a panel picture somebody sent that had three E1s side by side for three different people that needed access to it. I'm like, yeah, we've gotten way off track, because there is no necessarily security there. You're putting all your reliance of security on E1 or whoever it is to do the best thing. And that's not good enough. We need to know that our systems are secure. And so yeah, stay tuned on that one. Let's see. Happy New Year. Well, and Happy New Year to you. New one. Can you provide Alan Bradley simulator software name for P? Yeah, it's in the Connected Components workbench. So if you open up Connected Components, do I have a version? Actually, here you go. I don't have. Oh, no, I did not. No. Okay, that's not true. I was getting ready to say I didn't know that. Coincidentally, I have Connect Components Workbench open with a configurable safety relay, but right here in Connect Components Workbench, you have Start the Micro 800 Simulator. And so if I click that, and I assume it'll, yep, then that's going to pop you up a Micro 850 here. And so we see its IP address is going to be 192.168.2202. And yeah, we power it up. And it's going to warn you that it can only run for a day. And yeah, so you can just click right here and you can turn your inputs on. If you had a program in it, you could see them turn off. I think you can actually put plugin modules in it. I don't know. I don't get excited about simulators, mainly because, one, the simulators do not work exactly the same as a PLC. And I've ran into that. People will be like, hey, I'm trying to test this code and it didn't work the same when I got out of the plant. I'm like, what are you testing your code on? They're like, a simulator. I'm like, have you thought about putting it into a PLC? But you're getting ready to probably spend a large investment on a plant upgrade or doing something. Go ahead and get you a PLC to actually do some testing with. Also, going back to the whole sensor discussion, it's surprising the people that come to me. They're like, yeah, I know how to program PLCs. I can't figure out how to make an input turn on. But yeah, so you got to get a little bit out of the software there. All right, let's see. Who do I contact about getting my UL 508A certification? You contact UL. And I know that sounds like let me see if I can find this fast enough. Uh, gosh, now, yeah, I need that like ultimate list. Uh, Here goes. This one will work. It's not the one I was looking for. But so really, if first of all, if you like have never built a panel before, it's probably not time to call UL yet. But if you've been building some panels, because a lot of people are like, well, UL just costs way too much. Here is UL cost. UL cost. This is a few years old, but it hadn't changed that much. It's public information. Nothing that I'm giving you that's hidden. But there is a cost associated, with a yearly cost to be UL. I'm not going to remember off the top of my head. It's in that video. And then you have a quarterly inspection. So a UL inspector will come around quarterly. Now, the part that people blow smoke up everybody about is, well, if we make it UL, it's gonna cost you a lot more money. I would actually say that when I became a UL 508A panel manufacturer, our cost actually went down because I didn't understand a lot of the why of things, and I wanted to build a good panel. And so, I'm doing this and doing that. I was overbuilding a lot of things. So there's not a huge cost difference. And honestly, I mean, I bet you if you go look at it, most of your components, see if I can get it in there. Well, right there it is. If I can, whoop, wrong way on my finger. Whoop, gotta go that way. There, right there. I can't get to the focus on it. But those UL symbols are almost on all of the components. I don't, in fact, I'm trying to think back when I don't know that we had to eliminate any particular component when we started being a UL shop. Um, the big thing that everyone is deficient on, I feel you could almost say everyone is deficient on when they want to become a UL shop, is torquing and labeling. So probably you may right now, maybe you're torquing your power terminals. Every single screw in a panel, including those bolts that hold the panel on, have to be torqued to their specification by a calibrated torque wrench. So that was the big one. And even then, people were like, well, that's going to take me a lot more time to build a panel. Well, you're 100% right. And that's why we switched to push connects on everything. And man, I had never even thought about how much time a push connect could save. But first of all, you still got to screw the terminal down, and now all I got to do is shove a wire in. And I was like, man, I just never even thought it. So, I mean, like if you look at the back of this trainer, because it's based off of our control panels. And yeah, so we have push connect terminals. Let's see if I can give any zoom on that. So you're switching to them, that eliminates a ton of labor. And even these relays here are push connect. So eliminating every possible torque point is a big way to save money on that. But for the most part, that and labeling are the big things because chances are you don't have a nameplate label on your control panel. And well, can't read it from here, but a nameplate really just kind of shooting from the hip now. It should have the incoming power. It should have the amps of the panel. It should have the largest motor load. It needs a short circuit current rating, 100%. And no one out there is doing the short circuit current rating unless they're UL. And that's a very important safety piece. Needs a drawing number, needs, your basic contact info, things like that. But yeah, it's much easier than you think it is. And so I remember, of course, kind of like you're asking here, I asked on the forums and everything else. Oh yeah, it's really tough to get UL. And then finally I pick up the phone and I call UL, and I still don't know till this day whether I just hit the perfect UL representative or if it's experience every time. But they really walked me through exactly what the steps were going to be. And I kind of explained a little bit of, hey, I've been building panels and this, that, and the other. And, and really they kind of talked through, the things that they typically see that need done. And then they're like, and they wasn't even pushy. Then it's like, well, let me know if you're ready to, sign up and I'll get a contract written up. It was that easy. Then I had to go to a training. It was a all-day training. Was it one day? I think it was one day. Can't remember now. And definitely go to a UL center for the training. And yeah, I would 100%, even if you have multiple people, because you can get UL to come to you or you can go to them. That was a fascinating because it's done at their training centers and they do all their testing and everything, and it was really cool, well worth it. I would assume all the UL locations I think do some type of testing, so it's a really great experience to go there. And then now you need to take the MTR exam, and that is not the hardest exam I've ever taken, but you do need to do the practice test. Especially probably the big things in it were the short circuit current ratings. Really, that's the big one. You've got to understand how to do those. Um, but they have made it slightly easier. I think it used to, you had to sit down, you had 4 hours to do it, period, the end. I think it's broken up into 3 groups now. I don't remember what they are. Um, but yeah, so you have to do that every 3 years. And I would say everyone who is building panels should BUL. Um, it's just an extra layer of protection from liability for you. I mean, that was probably the fascinating thing about going down there. I didn't know it, but UL came out of the Chicago fire. It was really a company that kind of said, how can we make our buildings less susceptible to fire? And that's kind of what it's all built out of from there. So yeah, that's all I can think of on that one. All right, let's see where we got that one. Let's see. I have a Panel View Plus 600 to program. All right, so for that one, you will need Factory Talk View Studio and or Machine Edition. And yeah, I don't have anything on that. It's not one that I've ever been a huge fan on. In fact, I think I did a video on how to install it into a basic program, and I think I scrapped it all. I don't think I ever published those videos. Let's see. Can you give me your contact details? Well, you got them right here. This is where I answer questions. Unfortunately, I can't answer many questions, or not nearly as many as I used to in email. Um, on a super busy week, I can easily get 2,000 emails, and it's just not going to happen. Let's see. Are you coming live tomorrow, same time? No, I'm not. So I was just telling Mary Rose, I'm trying to get in the habit of doing it every week that I don't have a training class. So like next week I have a training class. I'm hoping right after that we're going to finish up our PID series. But no, right now you need to hit that subscribe button. In fact, yeah, if you haven't, you should go ahead and hit that subscribe button, and that way you'll know when we go live. All right, let me see. Where was I at on this? Let's see. All right. Well, actually, there goes your HMI question. Yeah. So, what is the best HMI to use? It's a common question I get, and I don't have an answer for that. The HMI you should use is the one that's already used in that factory that supports the communication protocol you need, is what I say. So, especially in this case, though, I have the Micro 800 that needs connected components workbench. I have the PowerFlex 525 that needs connected workbench, and the Panel View 800 that needs connected components workbench. So sometimes it's just for more of uniformity. Um, Again, starting out, there are plenty of HMIs that have free software. Like even you that was just asking that. I mean, that's going to be a paid software, and you can buy this Panel View for less money than the software would cost. So yeah, it all depends on what capabilities you need. Let's see, can you show me how to tie timers and counters together in a PLC program? This is obviously a student exercise. I get this one all the time, and I tell students all the time, go through that sequencing video. If you will go through the sequencing video, then you'll get an A on your class, and yeah, you'll know how to do all that stuff. What's the difference? Not the digital. What's the difference between a digital and analog input? So digital is what makes up all the on-off bang bangs of the world. So I press this button here. It's either a 0 when it's not pressed, or we press it and it's a 1. That's the only two values it can be. That is digital. Here we have a potentiometer, and we can turn it to different locations. This is analog because it's going to be in a range between 2 points. And so you can have digital inputs. We can also have digital outputs. In this case, this is an analog input because the PLC would read it. It can also tell this drive to run different speeds. So that would be an output. Oh, let's see. What is a shift register? How can it be used in a PLC program? Man, I was just going to scratch that one. I got the coolest inquiry the other day from a guy named Doug. I don't know if Doug's on here, but he is working on automating an old 1950s jukebox. Just doing it there, going back to how do you learn PLC programs? Find something interesting and just try to do it. So he wants to be able to not only store and retrieve records, but also store and retrieve the data and have people where they can request songs. Because you think about it, used to you could put your quarter in the jukebox and you could press what song you wanted, it would remember that. But so it has to store that. And we usually can we do like a first in, first out, or we can do a first in, last, you can do different ways. But yeah, it's usually for storing and retrieving data. Could be where you're locating parts. It could be things like that. But yeah, that if he goes far enough with that jukebox exercise, I think I will help him in a video on it. Let's see. How can you integrate a PLC with other industrial control systems like SCADA and DCS? Well, kind of going back to the earlier one on, well, I need this over Modbus TCP. It's understanding the language the two commonly speak. So I love the Micro 850 for stuff like this, or in general, is this thing can speak Ethernet IP. It can also speak Modbus TCP. It can also speak Modbus serial. It can, speak the old ABDF1. It can do a lot of cool things that, so we can tie it in a lot of different ways. Now this PowerFlex right here over Ethernet, it's only doing Ethernet IP. So in this one's case, we want to integrate it. We've got to have something that talks Ethernet IP. In this one's case, we can go a little broader. We can exchange data with something that can do the Modbus TCP or something. But for the most part, you're going to need to select some type of SCADA software. That's that ignition that I was talking about earlier. So you can select ignition, and it'll have drivers in there, which actually in our last live stream, or 2 live streams ago, we talked about trending, and that was kind of it. We were connecting ignition, which is the SCADA, to the PLC. And then we were actually reading the drive commanded speed and the encoder speed. So we're taking these 2 field devices, we're collecting them here, putting them into some type of value that works for what we're looking for. And then, yeah, we were shooting up to ignition, or you could also arguably use an HMI for that. What are the benefits of a PLC over traditional relay-based systems? And boy, I still have people that comment in my videos that we can do all this stuff with basic relays. This is all a waste of time. And time is the important piece of that statement. So I can take a PLC and arguably wire it and write the logic much quicker than I can make relay logic. And again, going back to the troubleshooting piece, this is the part that everybody building control systems misses, is I can troubleshoot a PLC controlled system like immensely faster than a relay logic based system. In fact, man, if somebody had a pretty compact relay control system, I'd almost be willing to do a programming challenge on that. I'll put Mary Bruce on the programming. I'll do the relay. I guarantee you she beats me every time. So, yeah, I mean, it's all about, when we're thinking about the time and we're thinking about the component costs, that's the part we never think about is how much does it cost to fix the machine? How much does it cost for the machine to be down? I mean, and nobody, and that's another thing, people don't identify their downtime. I want to do a video on that, but it's really complicated to do. Because there's so many losses in downtime that are just not identified and are kind of gray sometimes. But a small business's downtime is like $250 to $450 a minute. That's a minute. Medium businesses are around $20,000. I'm sorry, large businesses, but yeah. So yeah, that's the big thing. I wish it's not a matter that you can think through it in your head. It's not a matter that, oh, well, it's a lot simpler. Yeah, it's all about how long does it take for the average technician, not you, the average technician to troubleshoot the machine. All right. How do you handle errors and fault conditions in PLC programming? And along with that, why do you never write a fault handling routine? Well, probably the big thing is hopefully, I don't know. I have a mixed love-hate relationship for math overflows and fault handlers that try to clear faults and keep machines going. On one hand, you are keeping the machine going. On the other hand, there is a fault. Is the machine actually running the way it's supposed to run? And so that's why I've never really done the video on that. There is, to note, so you know what he's talking about here. Oops, where's my screen? There's my screen. Um, if you go into, we'll just go here because I think this one actually does have it. No, it doesn't. So up here, there's a controller fault handler, and you can create a program for it. And the controller fault handler really handles, and this is going to be a little generic because I'm not reading all the details right now, but it's going to really handle faults of the controller and all the IO modules. And then in here, in each one, which I bet I don't even have one that has a fault handler in it. I don't. But if we right click main program and go to properties, there's also, you can make a fault program here. And this would handle things like math overflow. When I talk about math overflow, you cannot actually count to infinity and beyond. So if we try to do something, and let's just go with the 16-bit number, a maximum of a signed 16-bit number is 32,767. So if we make something and try to put it in that is 40,000, 40,000 is not going to fit there. And so you're going to with that math overflow. And I got to admit, it was a little brutal in RS Logix 500 because he would literally take the machine down right away. Let me go online with this one. Let's just see. Talking about faults. If we're going to talk about faults, let's talk about, whoops. Wow, that was weird. I'm glad y'all didn't see that. I have no idea. Actually, I should have shown it. I have no idea what just happened, but it is online now. Is it online? It is locked up right now. Okay, I knew something seemed weird. Oh, there it goes. Okay, but if we go to edit and then controller properties, we have the major and minor fault tab, and these are ones that I do need to do videos on these. Now, the major fault, you're hosed. It's done, and we actually have some videos talking about this. In fact, that's a really good one to do. Let's see. Faults. This one, copy link. Dealing, whoops, with major faults. But we also have this minor fault tab right here. And okay, right now we don't have any, but very often you'll see one of these boxes checked here where there's some little issue going on, but it's not enough to actually cause the thing to do a major fault. And I really should, you can use a GSV and actually get this and bring it out into alarm. And we probably should do a video on that sometime. But as far as the fault handler goes, if kind of my philosophy is if you can handle the fault, maybe you can gather information and hopefully have some type of info to help us troubleshoot it. The one I don't like that a lot of people will do is they want to clear the fault on power up. And the next thing you know, people are always like, well, cycle power, that'll get that fault, and next thing they were cycling power every time something's wrong with the machine. So overall, I don't know. I will probably do a video on it eventually, but yeah, it's not real exciting to me. Let's see. Let's see. Why do we have the different internet protocols such as Modbus, Ethernet IP, and Profinet? Well, that's an excellent question, and that's because even here, some of us speak different languages. We develop different things. Some of them, unfortunately, is brand. Um, you know, I wouldn't call it proprietary because Ethernet IP is an open protocol. I think Profinet's an open protocol, but obviously Ethernet IP is what Alan Bradley gravitates for. Siemens gravitates towards Profinet. And I don't know, Modbus TCP is always the interesting one because it kind of feels like somebody like dropped a paper with a specification on the way out the door and somebody made 10,000 copies of it, but nobody ever really explained it. So it's arguably the universal protocol that nobody knows for sure exactly how to get everything to line up right on. Since we're talking about that, that's one thing I love about the Turk module and many others, but this one right here especially. Arguably, this is probably the best IO Link module to get something operating as fast as possible out on the market. So this does Ethernet IP, Profinet, and Ethernet IP, Profinet, and Modbus TCP with zero configuration. It can actually serve up all three at the same time. And yes, you can't go in there and disable the different ones, but that's what I like about it is really you can grab it and you can go pretty fast. Now, I didn't say it was 100% the best in the end. I have to admit, so I've been working with this 5032. Did I have the right program open? And what I really love about this 5032 module from AB is we can get the actual IO link modules or the components down in our IO configuration. That's a huge troubleshooting tool. Right now they're powered off, so we can see the 5032 is offline. But this right here is a distance sensor from Allen Bradley. This right here is a banner stack light. And so they've got it really where you can integrate a lot of good third-party devices into their IO link. So I really think that's just an awesome one troubleshooting wise. Again, in the long, a lot of it's long term versus short term. I like this because it's universal. I can learn this. I can use it with the Micro 850. I can use the Micro 820. I can use it with Automation Direct Click PLC. I can probably use it with almost every PLC out there. The 5032, it's Ethernet IP only, but it's got a lot under the hood, a lot of good diagnostics. So again, going back, there's no ever perfect one probably. Let's see, we'll do a couple more questions and then we're going to call it quits on this. And let y'all want to drop any other questions in the chat there. Let's see. How do you monitor? This is the one I get all the time. And usually this is I need to modify a program without shutting down the machine. How do you do it? If you are asking me how to modify a program without shutting the line down, you don't need to modify the program without shutting the line down. You need to go practice, 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 and probably, if it's that critical, bring somebody in, watch them, look over their shoulder. You're paying them; you can be right over their shoulder all the time and start to understand it. But we do have some videos on doing online edits. But online edits, I mean, again, you really need to test before you do something like that. And then, this is one of the, final one here. What is some of the best practice for optimizing PLC programs, performance and efficiency? I would 100% disagree with this question. Well, not the question. With people doing this. We don't need the most efficient and best performing PLC programs. We need the easiest to troubleshoot PLC program. And those are two different things. Kind of going, if you go into my sequencing video, it's probably the perfect example. Rockwell has a sequencing instruction. Thank goodness, I can't even remember what it is right now. The SQI and SQO instructions. And two instructions, you can really make any process work. Really cool. And so I was working at a plant one time and I went in there and, the maintenance manager's looking over my shoulder. And he's like, "Hey, what's that?" And I'm all proud, and I'm explaining to him, how it works and how makes it so much easier. It's only two instructions, and I'm running this whole machine. And he's like, "If you ever use that again, we won't allow you back in the plant." And I'm like, "What?" And now his point in the end was very valid. He's like, Rockwell has a sequence instruction. Siemens has a different sequence instruction. All of them have something different. If you make it the basic compare, are we on step one? Are we on step two? If you use those basic instructions that all of them universally use, then my folks can troubleshoot all these machines. Now, going back to our whole argument, of, well, shouldn't they learn it? Well, okay. Now we have a specialty instruction inside each brand. Now, I agree, they should learn ladder logic, function block, structured text. But if you start telling them you got to learn Allen Bradley sequence instruction, Siemens sequence instruction, Omron sequence instruction, Mitsubishi sequence instruction, then, then they're going to get a little hostile. And again, so going back to what is the best program, it's the one that the average technician can connect to and troubleshoot. Anyway, let's see. Do I have any other questions over here? Oh, Viper Gaming. Hi, sir. I'm from India. How can I start a career in automation? what can I choose as the first step? Well, we kind of hit that a little earlier. Just replay this video where we're talking about go find you the most common PLC that in your area and hit that subscribe button. That'll be important. Tim, can I download RS Logic's 5000 softwares without a license? No, you cannot. So again, if you need to learn PLCs, I stress this all the time. Do you need RS 5000 or do you just want RS 5000? You can get Connected Components Workbench for free. You're still going to learn the bulk of how, we'll call it the Allen Bradley, oh, what's the word I'm looking for? The general gist of how their software works, their culture. You're going to learn the same thing out of it. Free software, simulator, PLCs for less than $1,000. But that's all I got for today. Sorry, it's supposed to be an hour, 14 minutes over, but seems like everybody's having a good time. I'll talk to you later.